Hello, everybody. Thank you so much for your patience and greatly appreciate your feedback. This video I made is basically to answer many of the ideas and many of the questions that you had in your feedback. And we will start one by one. I actually wrote some of them, what you may see. So we're going to just go one by one and give you a little bit of uh, let's call it a review, okay, of what we're supposed to learn in this class. One of the things I saw is basically question that math is something that's not for everybody. This is an IT class, so I would advise to try to trust yourself a little bit more, okay? Uh, because once you start from the belief that something is hard, it will be hard for you to actually break that belief. You should start basically from the belief that you are here to learn and you can learn anything. And math is something that can be learned as well. Okay. So, luckily, in this class, you don't have anything uh, too sophisticated, too hard to understand, or we're not using any formulas that are too hard to grasp. Okay. And that's why we are here. I can definitely explain things if you have very specific points that you want me to go over. I definitely can do a video just on that specific point and explain it a little bit further, but I will go a little bit deeper in it. And I see that many of you are grasping things very well. And I will give you pointers and also I will give you some resources, some videos at least, that will help you understand more and go further in your uh, exploration, I would say. Okay, so that's one of the things. The other thing we saw is problem solving. Many of you have said in your reviews or your feedbacks that problem solving is something that you learned here. It is all about logic. Okay, it is something that you can understand from the logic, and you have it in you. Okay, we are born with that logic, and we can further our understanding if we explore it a little bit more. Okay, so problem solving is in you, basically. It is a logic that's programmed, I would say, and it is not something that it's foreign to your brain, I would say. Okay, so do not get intimidated. Anything can be learned, and problem solving is definitely one of the things that we love as computer scientists. Now, did see also some people liking more writing, and that's one of the reasons why I added discussions in this class, because it's one of the requirements for us to get engaged, okay, to get uh, some presence in the class. Okay, if you just receiving and receiving and receiving and you're not giving anything back, you are not really testing yourself, and that's the point from discussions. And you probably noticed the discussions, I created them in a way to drive you to understand what you need to understand to answer those assignments that you have. They're very close to the assignments, and in many cases, I actually made them in a way to drive you guys to teach each other. That is the entire point of the discussion. It is a conversation between you guys. It's very easy for me to go in there and start blurbing stuff and give you just pointers and here and there. But the point is for you guys to teach each other. Okay. I'm already doing my lectures. I'm already giving you feedback through these videos or maybe through the welcome to the week uh, announcements. But I want you to be present in those discussions. And I loved many of the things that you guys wrote about. Okay. And every time you write something, make sure you support your claims with some resources. And I did see many of you citing a lot of resources that others can actually go and explore. Another thing that's answering the question of why are we doing conversations or discussions, that's the reason. We want you to be more present. Okay. Another question I saw is conversions between binary and decimal. You probably saw we have many things that are actually driving us to understand what is binary, what is decimal, how to convert between decimal and binary to decimal. And I can tell you, the practical application for knowing those conversions is actually very felt and felt very strongly in networking. And I'm talking about network, not networking. Sorry, I meant network science, or basically how to create a local area network, on how to understand how to manage a local area network. When you have an IP address provided to you by the internet service provider and you have 50 computers in your network, how are you going to divide those IP addresses? Okay. How are you going to give every computer an IP address? Of course, if you're using DHCP domain, so that's basically automatically assigning those IPs, but you do need to know, or you do need to allow your computer to have, not computer, but I'm talking about your router and your network. This is at the network level. You do need to allow some kind of division of those IP addresses, what we call subnet masking. It's a science basically that will allow you to create multiple IP addresses. And to do that, you need to understand how to do calculations with zeros and ones. You're going to have numbers, you're going to have an IP address, and you're going to have to divide it, let's say, to 50 computers. Do some research about subnet masking, and you'll understand what I'm talking about. So, definitely, understanding conversions between zeros and ones and decimal, it will be very practical. And if you don't know it, you will not be able to do your subnet mask. You will not be able to assign IP addresses to multiple computers, and it's going to be very hard for you to know those IPs. Anybody who's going to Network Plus certification will understand this part. So it is good to understand conversions now while you have no other assignments that will basically test your knowledge deeply, like having to do subnet masking, but now you can understand it. So another thing I noticed, a lot of you loved talking about gates and circuits. Okay, I will make you a small video about what you can do with gates and circuits. In my days, a long time ago, we were able to play with gates. We were able to, and one of the tests we had, this is overseas in Morocco when I did electronics. By the way, I have an engineering degree in electronics way before I started any education in the US. Now, that uh, the gates and circuits were the cheapest thing that we had to play with. So one of the tests I was saying is we are given a pattern or a function, basically cosinus. We wanted to have two axes. I'm gonna share my screen real quick. I'm gonna leave my picture all the way down here. Okay, so let's use some pen. We have an A. Okay, let's change this to maybe right. An A and a B, and you want it to go into a function or some kind of an operation or some kind of a manipulation of the inputs A and B, right? And we want to get an exit here. And basically what we are given is the output. We're told, let's do cosine. Let's just do A, cosine A, for example, plus cos B. You may think, whoa, that's too much. You probably not understand how we're going to do the cos, because the cosine is a different equation and it's a trigonometry now we're talking. It may look hard, but no. A cosine is something that you can use with exponential numbers, exponential a. Well, I'm not going to get into details, but anyway, it can be converted to a different function that is actually made out of numbers. This equation we're gonna turn it into something in here, some kind of an operation, and we're gonna give an output. So those are one of the exercises. Whatever we have here, it's actually based on gates. Okay, gates, because they were cheap and we can play with them as much as we want. The problem we have is you're gonna end up with a huge kind of a motherboard, because this is not only building the logic of this equation here, but we're gonna actually build it. This is what we did. We built it in real. We went and created, we put integrated circuit next to each other, things like that, and how many we needed. And we connected between them, right? Connected between integrated circuits. We put an A in here, put a B in here as a wire, right? It's a wire, and this is a wire. And we use to control this between zeros and ones, and we wanted an exit here as an output. We actually built it, and we needed to use the logic first. We get tested on the logic, and the teacher will tell us, okay, you got the logic right, now go build it. We build it, we're given a day or two, we build it, and then we have to test that whatever we came up with, the equation here is actually implemented for real. For real, we test the logic, and we test the application. Now, this is what I try to tell you here, that gates are extremely beneficial, extremely helpful when you're trying to learn a new thing. Something that we got to the point once we find out that gates are too cumbersome, too much to do. So we started talking about, using computers or using a microprocessor. So what's the benefit of having a microprocessor? Microprocessor already have few elements inside. It has a memory, and it has an ALU. You probably noticed that we talked a lot about ALUs. It has a memory. If you didn't have this, if you go to the CSC 205, you will understand a lot more about computer organization. If you one of my classes, you'll see we went way deeper than just knowing what the computer does, but we actually went into what the operation system does, and how the memory is involved, and how is the information, the manipulation of the information goes through the memory and the ALU, and you'll have like a cache within the ALU. You have some microprocessor. So this is some of those things that you learn in other classes. But for this moment, all I'm trying to tell you is that gates get to a point where they become too cumbersome. You cannot execute much. You cannot do much with gates. So microprocessors is the way. Now that we have more advanced microprocessors, for these inputs and outputs, we use programs. You use programs, and we basically create with something more sophisticated, and we give it a program. And then we say, okay, in this program, you're going to have this many inputs, and you're going to do this based on this program and give us an output. Generally, the input will be a certain type of data, 16 bits or whatever, and the output will be something like a 16-bit as well, something that the memory can actually store. Okay, so I don't confuse you too much. That's just me telling you that the gates are good, awesome, and everything, but application-wise, you will not gain much from them. But it's good to understand how you can do them. Okay, we talked about gates. We talked a little bit about microprocessors. And something that I wanted to share is how did we go from, now that we have programs, how did we go from language that a human being understands into a language that the machine understands? So we know already that the machine only understands zeros and ones, right? Zero means there is interrupter. This is interrupter. So once you connect this line, then the information from here goes to the other side, okay? But if it is not connected, that's a 0, right? If it is connected, that's a 1. This is 0, this is a 1. In a way, let's say there is current here. In a way, we're saying if there is a current, it's a 1. If there is no current, it's a 0. That's what the machine understands. So now to go from a language that humans understand to a language that is a machine understands it. Machine only understands zeros and ones, 0, 0, 1s, whatever. Human have a language. Okay, humans have language, machines understand zeros and ones. So what we did is we went backward. We looked at the machine, what information it understands, and we started building software or programs that will allow us to give zeros and ones at the end. So we created what we call at this level, we call them high level programming. High level programming is basically language that you can read as a human being and you would understand. If you go to a program and you see words like add, and you see words like then, or you see words like if, those are words that we use and we understand them as humans. But the machine doesn't understand that. So you'll see a program, it gets created, and all that program gets turned to a bunch of instructions. So there is another conversion between the program to a different type of language, okay? And there is another type, I'm not gonna get into details, like assembler. And then you get to this assembler. These instructions are simpler instructions than these, and it will have more lines. Okay, for example, if I say add A and B, here it will say use addition, and it will say first number A, second number B, give result, store result in memory, output result in screen, stuff like this. So out of this instruction right here, we end up with many instructions. That's basically what we call another program, okay? And based on the assembler, we'll turn these into zeros and ones because it knows what's addition, so it knows the code for addition will be certain zeros and ones for the computer to understand. And then the next instruction, and there will be zeros and ones all over. And that's what's get fed into a CPU. Then CPU understand, okay, I have the first instruction, it's telling me it's going to use addition. Second instruction is telling me it's going to be addition between two numbers. Third instruction is telling me the first number is this, third number is this, and it's going to know where to send the information at the end. When it calculates it and everything, it's going to put it in the memory. It saves it in the memory, and then if it has an instruction all the way at the end saying output the information from the memory into the screen, then you'll see some results on your screen. Okay, this is the computer basically. But these are the numbers. I'm being too fancy now. Anyway, so that's how we go from high level to low level. The lowest the level, the closest you are to the machine understanding. And you don't understand this part. As a human being, if you get like assembly and you get like a list of instructions written in zeros and ones, you're not gonna know what it is. But the CPU completely understands what it is, okay? So the closer you get to the CPU or to the machine language, the lowest the level. The higher you go on this side, closer to the human language or the human understanding of language, you go into higher level programming, okay? So that's basically what it is. You're going to see it in many places, people talking about, oh, it's a high level programming, low level programming, whatever. You rarely going to touch anything about low level programming. But I can tell you, my very first interaction with computers was with a CPU and we were doing low-level programming. We actually were typing the zeros and ones and giving them to CPU in the form of zeros and ones. We did the instructions, we found the programs, and we wrote them by hand. And then we wrote the zeros and ones into a machine that only receives zeros and ones, like the keyboard you have in your keyboard, just zeros, 1, 2, 3, all the way. It's hexadecimal all the way to F. So it has all the way to 9, and then A, B, C, D, E, F. That's the hexadecimal numbering system. And that is it for that. Of course, if you want to learn more, send me an email. Tell me, hey, I want to learn a little bit more about this. I'll be more than glad to show you some videos or share something with you, because computer science and even deeper assembly language, I used it extensively a long time ago. That was my very first degree. It was just in electronics. And I'm not talking about fixing electronics. It's actually the electronic science, how the electron goes through wires and things like that. But at the end of it, of course, we had to actually play with gates and things like that. The other thing that I had a lot of people talking about in the surveys was the flowcharts. A lot of you loved them, and it's awesome. Many asked, there is no clear instructions. That is the entire point. The entire point is to not give you clear instructions. If I'm asking you to create me a program, how you want that program, it would be up to you to tell me what do you want in that program, okay? However you want to write the program, you write it. The goal is, you know, what's the output, what's the end. Let's say we're going to give two friends the coffee cups or whatever with some sugars in them or whatever. However you want to do it, you can do it. The entire thing is, at the end, I need you to give coffee or tea or whatever the test was. Every place, every time I change it a little bit. And then two friends. I don't know how many friends. You can actually put it in the program. Check how many friends in the room. Ask friend one if he wants or she wants tea or coffee. And then you're going to get into a point where you can have conditions. Conditionals are something big in programming. You're going to say, if friend one wants tea, ask how many sugar, how much sugar, or how much sugar he wants or she wants, and so on. You can go in details. At the end, you're going to create a program which is exactly like this. That's a flowchart or pseudocode, same thing, that will at the end give all the friends something to drink, right? And at the end, you're going to say end. That's it. That's the end of the program. That is a flowchart. Pseudocode is the same thing. Pseudocode, the only difference is we want you to write this instead of writing it in words. You're going to write it with a little bit of a logic. Basically, if there is an if there is, it's not a program, it's just how you see it, because we want you to understand every action that you ask the computer. We want you to go a little bit deeper, because the computer doesn't know. You're assuming stuff that the computer doesn't know. We want you to see that. And I accepted all the answers. Some of you created only few lines. I accepted it. Some of you created a gigantic program, and I loved that, okay? But I would not grade you if you did not create an if statement, for example. I mean, not grade you, but not penalize you, and so on. Okay, we're going to leave it at that. I'm trying to not go too crazy in this video, but I needed to talk about almost everything that we talked about. Python. See some people talking about Python, but I can tell you, you can learn Python very easily. There is a website can go to Pi for everybody. Pi for E. Pi for E. This is the website done by this Dr. Severus. You can go in there, you can create an account with them and everything. It's free. He put it in there for everybody. And you're going to see the lessons and you can learn. You can go to installing Python, how he does it. There's a lot of videos that you can see in here. Okay. Why programming? You can go to variables, expressions, and statements. You can go to these videos. They are all sitting in YouTube. And you can download these PowerPoints and go over them. I actually use this program and I shared it with a lot of my students. And a lot of them loved it. Okay. So you can go to this website if you want to learn Python and see that it's not hard. You can actually go through these lessons one by one. It will get, I would advise to go to all the way to regular expressions, chapter 12. Up to chapter 12, you wouldn't have a problem. Even if you never touch Python, you'll understand everything in here and you're going to feel a lot more comfortable using it. The advantage of learning Python now is you can actually use AI to understand and to create projects. But those projects, when the AI builds them for you, you need to learn how to read that code. Because if you don't know how to read that code, you don't know how to test it, or you wouldn't know if the code is actually right or not. Because, the AIs, they make mistakes. And you need to know because it gives you the idea, but then you have to actually test it. And a lot of it will work, but there may be a program that is too broad sometimes. Okay, so the rest of it, if you are a little bit more technical, you can go all the way to the end. Okay, network programming using web services, object-oriented databases, data visualization. All these last from 13 to 17. You'll have to spend more time and you'll have to be a little bit more versed, and you probably have to be a little bit more understanding to these 12. Okay, you have to go through everything that you do in this 12 if you want to go to 13 all the way to 17. And it is a good place to go to and learn Python if you want to do it. Okay, or at least look how to install it, how it looks like, and then do a little bit, maybe up to 3. Chapter 3, just learn what is a variable, what's an expression, what's a statement, and things like that. Condition, execution, function, and loops, strings, files, all that. You'll have to actually go through the chapter and play a little bit with it. You have to test it. You have to install it first and then test it. Okay. I use PyCharm. If you ask me what editor I use PyCharm, a community edition, and it's free. You can download it and use it, PyCharm, or you can use anything else. There is few advices here that Dr. Severus is sharing here in this website. Now, many of you talked about wanting to learn a little bit more about the hardware, how a computer works, and how does it do it. So once you learn a little bit about the zeros and ones, and once you understand a little bit more, hardware becomes a little bit easier, okay? Because at the end, it is just like you see in any computer science. If you go through the CSC 205, you'll see all this. So generally, you'll have a computer. You'll have an input, that's you, and you'll have an output. Generally, that's the difference between. So input can be keyboard, output can be screen, can be projector, can be anything. You may ask, how does it work generally? Well, the operating system is the master of this ROM, okay, or the OS. The OS is what manages the motherboard, that manages all the peripherals that's connected to the motherboard, and it manages how the execution of all the programs that are installed in your computer. So the OS is the one that manages everything. I may ask, well, I want to know a little bit deeper. The OS is a program that you cannot change. It's sitting in the back end of the machine. You can change it, but this program uses drivers to talk to all the peripherals, just like the word driver means, okay? These are perif. So it uses peripherals to uses drivers to talk to all the peripherals, like a printer or whatever it is. And it uses uh, some other tools to talk to the programs that are installed in the hard drive, okay? Programs, and this is the hard drive. So there is a communication in between the OS and all these things. And the OS is extremely sophisticated. There is a little bit, there is a learning curve to understand what the OS does. But at the end, it's all about those zeros and ones, right? The logic, the OS is the one that provides the logic, how to communicate with the devices, how to communicate with the input, how to talk to the output, and how to save the information in the hard drive. Okay, all that is done by the OS. The communication itself is done through certain type of programs. Every OS has its own way of communicating, and at the end, it's all about two things: the way the CPU receives the information. It receives it under two formats. Okay, it will be data and instructions. Two things: data and instructions. Every time anything is going to the CPU, it's coming in the form of a number, and in that number, some of it is data, some of it is instructions, or the opposite way. Some of it instructions and then data, instructions and then data. What is it? What's the important about data and instructions? So, instruction is basically to say add. That's an instruction, and the data will be 0 plus 1. It's what are you going to do with that? And then within that instruction, it's not only saying add, it's saying add the numbers I'm going to put next from cell this to cell this, and save the information in cell whatever. So you're given exactly what needs to be done as an instruction, and you're giving data. But you have to think any program will have something like this, but it's going to have few thousands of them. Okay, that's as we go back to the idea before. When you have a lot of instructions, it get converted to zeros and ones, and it gets put to the computer or to the CPU, and CPU will execute it. Okay, so just if you want to know exactly what it does, it gives instructions and data. And even as it gave instruction, it's going to say the data where to pick up the data from. That's why it's always connected to memory. Memory saves the data. And there is a cache, is just or called that we call it registries. So registries are closest to the CPU. Physically, they are closer to the CPU, and memory is further away, but the memory is large. The registries are small in size. Okay, registries are small, but it's important to have them small, so the information CPU will bring something from the memory. This is the memory. Bring something from the memory, put it in the registry just for a little bit of time, and then use it, brings it back to the registry, and then save it in the memory. Stuff like this happens all the time, but in the nanosecond levels of speed. Okay, so don't want to confuse you too much, but I'm just giving you a little bit of an idea what happens in a computer. Stuff exactly like that, but very fast and in the range of thousands and maybe even millions. Okay, we talked a little bit about Python, we talked about hardware, and I had some questions about the COA. What's the purpose of the COA anyway? We already put it in I'm submitting it in the same assignment. The assignment says this, so you know what I'm submitting is this assignment. Believe it or not, a lot of people actually make a mistake and submit stuff in the wrong place. That's one. Two, it's not that I want you to tell me what you're submitting. I want you to sign a piece of paper that tells me that you actually did the work. That is the purpose. Plagiarism is a huge deal. If you mess up and if you get into a problem with plagiarism, your academic career is over. So know that. And Laurel Ridge made it very clear they wanted to use COAs, Certificate of Authorship. It took many weeks for many of you to actually look at the COA or understand where it's sitting. That tells me that you did not go through the Start Here module. That is a requirement in every class you go through. When you see a Start Here, you have to go through those pages in the Start Here. Okay? The reason why there is some things we want you to understand, we want you to see and know. If you don't go to the Start Here, you're going to miss out. And I was very lenient about the COA. Many of you did not submit the COA. I'm making this video also to tell you from now on, only a few weeks left, if I ask for a COA and you don't put it, you're going to lose points. The COA is a priority. If I tell you to put your assignment in the page 2 of the COA, that is what you do. You put your assignment, whatever it is that I'm asking you, in the page 2 of the COA. If I tell you I want you to submit a paper and I want you to write me the COA separately, you're going to write the COA, put the assignments, but the paper you can submit it on its own, because that's how you're going to get the plagiarism report, because everything is going through Turnitin, and we're going to see what similarity report will come up with. Okay. And we want you, if we are testing for a similarity report, and we do that for everything I ask for, if I'm asking you to write something, just know it's going to go through Turnitin. You can go to Turnitin yourself and see what's your similarity report score, and you need to lower it. Generally, if you have a paper done and submitted by itself without the COA, I want you to have less than 25%. Okay. If you go over 25%, we have a problem. Did notice many of you wanted to know or wanted to get some resources, extra resources. I do provide a lot of resources for you for every class, but I did have some feedback in the past, some people telling me you're giving us too much to look at. The extra resources, additional resources I give you, those are not mandatory. But if I'm giving them to you, it is something good to have. At least save that stuff, okay? Create a Word document. That's what I did. I probably shared with you. I did 8 years of online classes, and I did almost 9, not 9, almost 6 years or so in classes, in between classes, in person classes, / with some of it was also virtual. So I know exactly what you're dealing with. What I did in the past, every class had its own folder, every discussion has its own file, and I had a file specifically for all the material I wanted to save for later. Okay, so I save links to websites, things that I liked and I wanted to get back to. I know where to find it, and I have one Word document that has all that. Word document is gigantic, but it's specifically for that class. Okay, and I title it in a way that I can find it if I need it. So I would advise you to do the same thing. This way you can have a Word document that is searchable. You can just type in words and it come up with what you have. And plus it will help you later. If you're writing papers later on, if you're in the 3rd year, 4th year of your academic career, you can simply find that file, do a research, and find some sources that you can use for other papers if you want. Writing. I had some people saying we love writing and would like to see more writing because they like to do the writing. So, and I did make sure I have you write few things during this class, and you're going to see you have still more some. There is a French proverb that says, tout ce qui passe par la plume passe par la tête. It means everything that goes through the pen or the plume goes through the head, meaning it more you write, the more you remember. That's basically what it means. We want you to do research. We want you to write something, of course, definitely. But we don't want you to just write what you know. Research is the key. Once you get a credential next to your name, then you can write and you can just put name in there and it can be cited by others and they can put your name as the one who wrote it, right? But for now, while you're going through your education, it's important to do your to study, do the research, and write stuff that is supported by sources. And that's the purpose of writing. Okay. So a good job on many of you who actually wrote something great, and I loved reading what you have written. Another question: why some assignments are not too deeply explained? Why uh, I don't explain some of the assignments? I went over this when I talked about the flow chart and things like that. We want you to have a little bit more freedom in your research. Do your research and provide the what we asked for. Do not expect that we're going to explain everything for you. If I didn't explain much, that means I'm giving you some uh, open space for creativity or for research and take advantage of that. I want to see how good you will do on how is your research and how hard you worked on it. And that's something that uh, gives you a chance to shine. That's the whole purpose, okay? The more effort you put in these classes, the better you will be in the future. And you do not go through a class where you had to study something and just pass through, okay? Uh, I can give you my own advice. Everything I studied, I actually gave it my all because I did not want to pass through a class without making sure I understood everything in it. Everything in it, and I mean it, okay? And you probably see my accent. My very first classes, they were very hard, okay? Not because it was uh, I'm stupid or anything like that. No, I actually am coming to the US with a nice degree, but it's because did not have the right words to put together, did not have the skills to actually write stuff that I understood in another language, but now I have to explain it or I have to present it in a way that's understood in English, right? So it was very hard, but I can tell you, perseverance and commitment is your secret. If you have that, you get to a point where it becomes a second nature. If you'll get to a point where you are not overwhelmed, it gets to a point where you know how much effort you need to put in to get the results you want. Okay, that's the purpose. And luckily, the class is not overwhelming, and I hope that, as I saw in your feedbacks, that you're all in sync about this because it is definitely not overwhelming. And again, remember, this class is now uh, in some classes it's 14 weeks, some classes are 10 weeks. So if they are 10 weeks, that means we took the 14-week program and we shortened it into 10 weeks, but we had to go through all the material. So you'll see more for a 10-week class, but it's a lot easier, of course, for a 14-week. I do remove generally stuff from a 10-week, especially some assignments that I don't need to overwhelm you, but generally I'm fair with the workload for this class. Another thing, notice some people asking about time management advice. What do I do with time management? Okay, great question. I love these kind of questions because it was uh, one of the keys for me to actually study and go all the way to a PhD because the secret is to create something that's repeatable, a process that's repeatable and that does not overwhelm me. Okay. And the way you do that is to learn the beginning of every class. I go over the syllabus, I know what it is, and I go over the weeks and see how the weeks is laid out. Okay. And because the week is closely similar, you will see at the beginning or maybe through my announcements what is the expectation. Generally, that's what I did in previous classes. I want to know what's in this week just in one place, and that's what I am doing for you guys. One place, you go to the announcement, you're going to see, okay, this is what we're going to go over this week. But I would advise to go through the modules and see exactly what's in the module for every week. So, well, the way I did it in the past is this: first day of the week, I see what's coming, what's in this week, what's the workload of this week, and I give it an hour or so to see what's in there. If I can do the discussion right there the first day, which in your case will be Tuesday, I'll do it. Okay, maybe 30 minutes or so, and I can put in the discussion first initial post Tuesday. In my classes, they work generally Wednesday or Thursday. That's the deadline for the initial post. We may ask, well, why do you have it Wednesday? Common sense, right? We want you to write something to give the option for other people so they can reply to you. If you don't put your initial post until, let's say, Saturday, you're not letting anybody, you're not giving anybody a chance to answer your stuff, especially if they submitted their stuff on Tuesday and then on Wednesday or Thursday they did their 2 replies. So nobody will reply to you. And I can tell you, in previous classes I had with other universities, if you don't have a reply, you lose points. Weird, right? But that was the case in some of my classes. That means not only you have to create your initial post, but you have to make it appealing enough for others to actually reply to you. Okay, we had something that we needed to do, like we emailed each other, hey, can you please go and reply to my post? Because if nobody replies to your post, you're going to lose points. It may sound weird, but it is something or some way for us to, not for the teachers, for teachers I had, to push us to get to basically engage other people in the class. Okay, but we're not doing that here. We're not asking you to reply, or if you don't get replies, you lose points. We just want you to reply to others. Initial post by Wednesday, Thursday, depending if we had a day off or something like that, and final post by the end of Monday, because your first day of the week is Tuesday. Now, that's basically for the discussion. For the papers, if there is a paper, if there is an assignment, I usually go over that early in the week. Okay, Monday, Tuesday, I will probably look at that assignment and what is it about. I'll do my research, see if there is something about that assignment that I needed to understand, and then from there, I start with it. Tuesday or Wednesday, I start with the assignment. If I finish it by Wednesday or by Thursday, I'm good. The goal I had, and I can share with you, not to be overwhelmed, is to generally leave your weekend alone. I did not do any studying during my weekends. Everything is done by Friday. Everything, papers, assignments. This way, Saturday or Sunday, I don't have nothing, no class. I don't do anything or school related. I wanted to work during the week at night. Sometimes I stay late until I get it all done. And the purpose is so I can relax on the weekend. If you stay stressed out about your assignments during the week and then you don't finish them and you have to do them during the weekend, you're going to have a continuous stress, and that is not good for you. Okay, I can tell you, you have to have a couple days a week where you are distressing, where you're not thinking about nothing. And if you don't do that, you will continue, that stress builds up. Okay, the stress always builds up. If you get to a point where it's too stressful for you, you may want to stop the class and you may want to withdraw and things like that. No, do not do it. Stick to it, make it a habit, and it will be easier for you. So it's always in the planning, and that's the secret. You have to plan your classes. I see also some people having a problem with assignments. I missed this assignment or I missed. No, you should not miss any assignments. The way I did it, calendar. I have a calendar. It doesn't have to be fancy, just like a Google Calendar. And I put my Google Calendar, I put stuff in it. Anytime, on Tuesday or Monday, the first day of class, I put the assignments in my calendar. And I remind myself by what time I need to finish this. Okay. Because I know if something hard that needs a lot of studying, I know it's going to take some time. But if not, if it's something I know it will take me an hour or 2 hours, I'd rather do it during the week and get done with it. Generally, as I said, I very, very rarely have to do something during the weekend. But generally, I don't because I take care of it early enough. So we talked there about the discussion, talked about the assignments, how to manage them. I get some ideas also. Some people asking me why not putting stuff on YouTube because YouTube have some capabilities like timestamps and things like that. I'm gonna try to do that for all my videos, but you may or may not see that because I have to upload the entire 18 chapters for this class, and each one of the chapters, as you probably saw, it's between 30 minutes and 45 minutes, so it's going to take some time. But I will try to do that, hopefully, for the rest of the class, and we'll do that for the next semester as well. And some questions about AI. Okay, people asked, how do I do to learn more about the AI? There is a class. Let me see if I find it here. There is a YouTube class from Harvard that is absolutely marvelous. I actually love that YouTube class. Let's see if I can find it in my. If I find the YouTube class. No, it's gonna take forever. Anyway, I should have looked for it before, but you can do some research. It's a YouTube class. I think it's called CS50. CS50. No, that's for Python. Yeah, this one. Yeah, it is CS50. CS50. CS50 from Harvard. Just to CS50 Harvard, and it should come up. And the Introduction to Artificial Intelligence. So this class is, I love it. There is many of them, CS50 classes that you can find in YouTube, and that's where I would start. Okay, the CS50 in YouTube, and that will give you a lot. The problem is they are sometimes too long, and you just have to divide your time. Okay, and do it. Listen, watch, and learn a little bit more about LLMs and learn about RAG and things like that. It is stuff that's the very beginning. It's not hard, but after you'll see that there is a lot of efforts in it, and there is a lot of teams who are working together to create and teach those AIs. Okay, I think I talked a little bit about almost everything that was mentioned in the feedback. I am doing this video for you, so try to take advantage of the moment. Talk to me if you need any feedback, if you need any help, talk to me. And I apologize if I missed some of you. It seems like I had one time that I couldn't talk to, but it was traffic, and one time I had an accident too. So forgive me there. But if you still need me, of course, email me and we'll make some time and we'll talk. Okay. So thank you again for your time and patience, everybody. I appreciate all the hard work you're doing, and know that I am with you. Although we don't talk all the time, but I'm on the other side. I'm looking at what you're doing, and loving almost all of it. But please put in the effort and stay committed, and you'll be fine. This class is almost over. Email me, call me, whatever you need to do. And thank you for your time and patience, everybody. Have a good evening.